There's nothing inherently wrong with a monolithic app. If it's well designed and maintained, there just might not be a good reason to change. However, given how things work in the real world, this usually isn't the case. I don't know your story, but I can make some guesses that I hope resonate, because I've been there. Almost everyone I've worked with has been a conscientious engineer, but sometimes the constraints cause them to make choices that cause problems for somebody else or that they have to deal with later. It can come from something as innocuous as adding a feature to an existing app without taking a long-term view of things. I'll just add this here. After that happens a few times, inertia takes over. Before you know it, you have a nest of dependencies that's hard to manage, and maybe your app has become brittle, or it's just becoming difficult to make any change at all. Hi, I'm Waldo. I'm a tech evangelist for Datadog. This means that normally I get to travel and meet people and advocate on your behalf back to the company. I'm a recovering operations engineer, and I've been active in the DevOps community for quite some time now. I also enjoy sampling various beverages and collecting hobbies that I don't really have the time to partake in. Now, while I'm not terribly interesting, my company is. Datadog is a SaaS-based monitoring and observability platform. We have over 450 integrations covering all the most common applications and cloud services. We ingest tens of millions of data points every day. As you might imagine, this leads to quite a few interesting problems. Perhaps unfortunately, there's no definitive definition of microservice. This caused some quibbling about what makes a microservice, especially around the idea of size. At its core, however, a microservice is an extension of a service-oriented architecture. There are a few properties that are often associated with microservices. Abstracted means that you can use the service without having a detailed knowledge of the internals. There's another way to say that the application is API-driven. You only care about the inputs and outputs of the service. Reusable means that another service that needs the same work done can use it as well. By autonomous, I mean that it contains its own logic, meaning it's not a wrapper for something else. Also, the service doesn't need to be deployed in lockstep with other applications. Stateless means that it doesn't persist state from previous requests within itself. This implies that it either returns all results to the requesting service, or it persists the data externally, such as to files or a database. Discoverability means that other services can find it in something like a registry. And finally, composable means that you can combine this services along with others to assemble a useful application. Now, I have to reiterate that this is not hard and fast. This has been more a set of properties that are especially common to microservices. Now that I've described some of the properties of a microservice, you might be wondering why you'd want these qualities, or why you'd want to write your applications in such a manner. There's actually quite a few reasons, and to be honest, it's not all hype. Microservices allow us to keep our architecture loosely coupled. This allows you to deploy individual components when they're ready in small incremental batches. It also allows you to make smaller experiments that are easily swapped out into and out of use. When your product components can be built, tested, and deployed in smaller pieces, independent of one another, you experience a much faster velocity and agility. Faults may be resolved more quickly, and experiments are less risky. With a faster feedback cycle, your engineers are less likely to fall out of their mental context when a change is needed. Again, with small components, you can go from idea to production much more quickly and cheaply, with that feedback available much sooner. Fact: small apps deploy more quickly. When you have a scaling event, it takes time for the new instances to be created, whether you're deploying containers, server images, or code directly to longer-lived servers. Additionally, by keeping your app small, you can deploy more servers in a size-appropriate manner. That means you can increase capacity by smaller increments and not have to wait until you're at your limit before adding additional servers. Because your apps deploy more quickly, deployments and scaling events can be set to be much more responsive. So you don't have to worry about leaving yourself enough time to deploy if you have to scale or replace failed instances. When you deploy an app in an SOA, implementation details don't matter to the other services. Nobody cares whether you're a Java shop or Python shop or whatever. It's because you've published an API. As long as the inputs and outputs don't change for the requester, what happens behind your interface is nobody's business but yours. Finally, most cloud providers are designed to host lots of small things. They're generally just not as good, not as responsive with large ones, and those large instances come with very large costs. So sooner than later, you're going to have to figure out what new apps you're going to be making as you peel components out from your monolith. How you do this will vary widely, depending on many factors, such as the engineering talent and that you have available to you, and how messy your monolith is. Various parts of your monolith probably already have nouns and verbs associated with them. Thinking of those individual sections as separate nouns and verbs is a relatively simple way to begin identifying new products to spin off into new services. There are two very real pitfalls that you need to be aware of: analysis paralysis and definition arguments. Obsessing over the right size to make your split off apps can be a huge time sink. It's more important to begin the process of splitting off new services. And arguing over the sizing is silly, but it can turn into like a huge bike sheddy time sink if you let it. If you find that your new service is larger than you like, making a mid-size SOA type service into two smaller services later on is much easier than splitting it off from the monolith in the first place. One method that I've learned for identifying components come from Sandy Metz and her philosophy of writing small things. What I've learned from her is to ask the thing what you're inspecting, whether it's a service or method or an object. What is it and what does it do? If that component's answer includes the word "and," you don't have one thing, you have two. There's nothing saying that you have to use this method, but it's something I found that works for me. Now, as exciting as the work is, and I know you want to dive in, you're going to have to do some due diligence up front. This takes some time to sharpen your axe, find your gloves, and stretch. First, you want to identify your current components and how they're currently referenced. I encourage you to create a dashboard that shows each application endpoint for both the monolith and the new services, so you can visualize your team's success in migrating requests. This dashboard will also help you hunt down components that aren't used anymore and aren't addressing the new versions properly. Using the components and interactions, you want to make sure that your written code is properly tested automatically in your CI, and that your application's functionality is properly monitored in production. The service contract also includes an intention of problems that the service will solve, as well as things like expected load, error budgets, and guidelines for the API reference. This may seem like unnecessary paperwork, but it's important for your quality of life. Describing the functional parameters that you prepare and test your application against will help set expectations should you suddenly find that your app is falling over when traffic surges unexpectedly. This doesn't absolve you of your need to be available and to build a resilient service, but you can at least describe the load that you tested for. Now that you're fundamentally changing how your applications operate, you need to make sure that the results are the same as they were before when they were running within the monolith. This ties in directly with the red-green refactor of paired programming, because that's exactly what you're doing, a huge refactor. Since you're thinking about testing, it's also a good time to make sure that your monitoring relates to the important tests. All right, now you're ready to get to work. It's time to break off your first chunk. I recommend that you start with your peripheral services. This doesn't necessarily mean a particular category of application, but rather look at components that don't rely on core business logic or heavy interactions with other services. For your first services, I want you to look for easy wins that help build new habits and help teach lessons with lower stakes. It's at this point that you want to start considering how you want to manage your application routing. This is something you're going to need to solve, and ideally it's something that can be toggled live and real time. If you find that your shiny new service is missing something vital, you want to be able to roll back your behavior quickly without having to redeploy or restart a whole fleet. Getting this right will be vital in the long run, but it's also important to remember you can iterate on this over time. As you go, you're going to find that there comes a point where you're not sure on which thread to tug. As new services are pulled out of the monolith, you probably need to continue updating the services that have already been extracted. This is where that dashboard I mentioned earlier comes in handy. Using your logging and dashboards will help you to hunt down components that are using the old instances, but it's also a great reminder to celebrate your successes. Now, remember, there's no strict definition of microservices. We humans like to categorize and define, but nature can be messy. If you have highly dependent components, it might make more sense to leave them as macroservices for now, and that's okay. A few larger services are generally still going to be better than a monolith. You still get many of those same benefits. And again, this is something you can iterate on. You can go back, you'll get better at it as you go. And like I said, it's easier to split up an SOA a macro service than it is to peel off from the monolith in the first place. Now, if there's one guiding principle, I would recommend that you optimize for your team velocity, second only to customer experience. Additionally, it bears keeping in mind that different teams may choose different optimizations. That's okay. Potentially more disruptive, but I think vital for your long-term sustainability is the move to product-oriented teams. A product team is a largely self-contained team that is tasked with solving problems. The team, like I said, is largely self-contained, meaning that it creates and runs its own solutions. And autonomous, meaning that it's up to them how they solve their problems. Product teams are the polar opposite of what is referred to as the studio model of funding, where a team will work on consecutive projects. It's so named from the film industry. In general, the studio model, or funding based on projects, works well for products that aren't run as a service, such as mobile apps and games that don't have like an online component. But in the product team model, it's the team itself that's funded, and it's tasked with solving a set of problems, which they implement and run long term. Now, if team funding models doesn't make sense to you, enjoy that you've lived a blessed career. In my experience, the studio model is leaning into the idea of throwing code over the wall for someone else to deal with, and it's a really good way of turning out legacy code. This is in contrast to the self-contained product team that runs its own solutions, which I personally consider the definitive implementation of doing DevOps well. Now, the last thing I want to talk about is a charter. This doesn't have to be a huge, complicated document. Its main purpose is to establish a set of problems that the product team is responsible for, and a manifest of people or skills who will be dedicated to the solving of this problem. This too is something that can be experimented with and iterated upon over time. Now, for now, give them a problem to solve and get out of their way. In my time with you today, we've talked about the benefits that you may seek to gain by splitting a monolithic app, the due diligence and planning that you should do before you initiate your new Git repo and start writing your new microservice, and how to think about new services in terms of the new applications and the teams that will service them. With that, thank you for your time.